And so we're back with more geometry and more circles. So today we are going to learn about the chords. What is so special about the chords of a circle? And so here we have two chords and they intersect, right? We have chord AB and chord CD. And these two chords intersect at E. Yes, they intersect at E. So what is special about this intersection? Okay, so let's first talk about these two chords we're going to partition them, okay? And so the word partition, what does this word mean? Simply, it just means to split up, okay? We're going to split these two segments up. And so we're going to split them into 4 segments in a very special way. This is the result. So we end up with the product of ED and CE is equal to AE times EB. This is the result of the chord theorem. Specifically, this is talking about the segment, okay? This is specifically talking about the segment. So what does that tell you? All it tells you is that if you have two chords and they're intersecting, the product of one chord is equal to the product of the other chord. That is all we are saying in this scenario, okay? But wait, there's more. Okay, well, what about the angles here? Notice that we have very special kind of angles. I don't know if you've noticed yet, but we have vertical angles. Yay! Remember, vertical angles are congruent, okay? So this angle here is congruent to that other angle because they are congruent. Notice that the center of the circle here is O. E is not the center of the circle. Please do not confuse that. So let's see. What is the special about the angles here? And now we have the intersecting chord theorem. But this theorem specifically talks about the angles, okay? What is special about the angles here? Let's see. So if we wanted to find the measure of angle DEB, referring to this angle here, okay, what do we know? Well, we say that the measure of angle DEB is equal to 1/2, okay, 1/2 the sum of the intercepted arcs. So the two intercepted arcs are DB and AC. Very simple, okay? These two angles are equal. Therefore, these angles are going to be half of the sum of the intercepted arcs. And there is a proof about that, but for the purpose of this video, I only want you to know what the theorem says. So if I can replace this angle with what other angle? Well, yes, I could replace it with the measure of angle AEC because they are vertical angles and they're equal. Let's look at an example. Before you guys target any questions here, I want you to ask yourself these 5 questions that I have laid out down here, okay? Write these questions down. They're going to be important, okay? So which theorem applies, okay? So in this question, I'm given that I know the measure of arc LW, which is 40. I know the measure of arc KL, which is 100. Okay, and I am looking for the measure of LZW. So I'm looking for that angle, and LZW is right here. So that's what I'm looking for, okay? Well, I have to think to myself, let's go through the list. Which theorem applies? Which theorem applies? Remember that we have 2 theorems. We have the intersecting chord theorem for angles and for segments. In this case, I'm looking for an angle, so I'm going to use the angle theorem, okay? What are all the parts needed in the formula? Well, if I wanted to find that, I'm going to rewrite the formula. That is the formula here. And what is it that I am trying to find? I'm trying to find the angle. So I'm going to rewrite that piece. That's the unknown. And I know that LW is 40 plus KT. Well, what is KT? Let's be a little sneaky here. KL is 100. That means that I have half a circle here, and I know the whole circle is 360. Half of it is 180. Therefore, this piece here is 80. Okay? Well, 1/4, so I have 40 plus 80 there. That is the formula. Now all I have to do in my final step is solve. Therefore, we have that this is 60 degrees. The measure of angle LZW, it is 60 degrees. Now you also apply these 5 questions when solving any problem. Here's another one. Okay, well, in this case, I have to solve for OC, okay? The length of OC. What is the measure of OC? Well, which theorem applies? Again, for this one, I'm solving for a segment, okay? Therefore, I need to know the intersecting chord theorem as it relates to segment. Replace what I know. Here's your check for understanding, okay? You have circle O. You know that the angle of the measure of angle DEB is 36 and the measure of arc AC is 42 degrees. What is the measure of arc BD? Once you're done with this check for understanding, which you have space provided in your lesson, call me over so you can move on to the lesson.